Create extruded cuts. In this video, we'll create an extruded cut, project a sketch into a sketch, and an extrude at a face, and use combine to add bodies together. In Fusion 360, we want to carry on with our gear reduction housing solids. The first thing that we're going to do is we're going to roll back the last extrude cut that removed material from the front housing. I'm going to create another extrude by selecting extrude and selecting the front face. We're going to go to the gear housing thickness. So when we take a look at this, you'll notice that as I type in the letter G, even though housing wall thickness doesn't have a G in it, I can still navigate through all of those parameters. I also want to make sure that this is a new body, as it'll be a cover that gets bolted on. We expand our bodies folder. Now we have a body 3, and we can roll the end of the timeline back past that extrude cut. There are many other areas where we need to begin removing material, so I'm going to start by hiding body 2, and I'm going to take a look at this face and begin removing some material. If we take a look at our sketches and our housing layout sketch, we already have a sketch in here that will allow us to remove some of this material, but it's not complete yet. So I'm going to get started by creating a new sketch on this face by selecting it, then right-clicking and creating a sketch. Then I want to bring back my housing layout sketch, and I'm going to use P on the keyboard to project some of these sketch entities. I'm going to bring in the outside diameter of the bolt hole locations. I want to bring in the diameter of the inside of this cut that we're going to remove. And I'm also going to bring in some of these outside diameters inside this small area. And I'm going to bring in this edge as well. I'm going to say OK, and then I'm going to come through and use offset to bring this edge in. And it's going to come in a value of 4 millimeters, but I'm going to use the minus sign, and I'm going to add the gear gap parameter. The gear gap parameter right now should give us enough offset inside of here. We can validate this by taking a look at the original layout sketch for the position and the size of the gears. Remember that these values are actually the pitch diameter, so it's in between the teeth. We're not 100% sure if this is going to be enough room. We can always go back in to change parameters, even inside of the sketch. We can take a look at some of the values that we have. You'll notice that our gear gap right now is 5 millimeters. And if we take a look at some of the other parameters that we have, you'll notice that our gear thickness is in here at 8 millimeters and our housing wall thickness is 3 millimeters. So what I'd like to do is come back and modify this value. And this is going to be our minus housing wall thickness value, which will give us a little bit of a smaller offset. We're going to use that value for now, but note that we might have to come back and change it. We're going to go back, hide the original layout sketch and the housing sketch to take a look at our results. What we want to do from here is finish our sketch and create our extrude cut. We're going to take this inside area as well as some of these other areas that we've created and begin dragging them backwards. As we do this, I'm going to enter minus, and then we need to use our gear thickness value. So the gear thickness value should be 8 millimeters, and if we say OK, we can validate that by going to inspect and taking a look at the depth from the top face to this bottom face and noting that it is 8 millimeters. So everything there looks good. Obviously, we will need to make some adjustments to the housing, but this is giving us a good start to make sure that we have enough room or clearance for those gears. Once we actually create our spur gears, we'll be able to see a little bit better the different areas that we need. We can always go back into any of these sketches and make adjustments as necessary. For example, if I want to use project by hitting P on the keyboard and bring in this edge here, and then offset that edge, making sure that chain selection is turned off, I can bring this one in that same minus 3 millimeter distance, and we're going to use that housing wall thickness value and say OK. Using my right-click marking menu, I can repeat that. And this is going to be a minus housing wall thickness value on this side as well. And those lines can be extended out until they intersect this projected edge. And they can do that by simply drawing a new line that is collinear. Depending on which constraint gets automatically applied, you might note that it's parallel or collinear, and you'll notice that it looks like it extended it for us. We're going to finish the sketch. modify our extrude cut, and we can come back and we can reselect some of these areas that we also want to extend and remove. By hiding sketch 5, you can see that looks a little bit cleaner and gives us that consistent wall thickness. We view this from the front and pull it to the center of our screen. We've now removed a large amount of material from the center of this back portion of our housing. If we bring back some of the other bodies, you'll notice that now we have room for gears on the front side of this, which will be our driven and idle gears. Our long idle gear will go through the front of this housing all the way to the back housing. And this other piece is simply going to be a cover. And this will give us a position to have a counter bore for things like a shaft that runs through some of those gears. There are other areas that we need to remove, so let's hide body 3 and show body 2, and let's start a new sketch. We're going to use a center diameter circle and set this to 21 millimeters. The 21 millimeters is going to represent the outside diameter of the bearing that's going to get used in the middle of this housing. I'm going to say extrude cut. I'm going to begin dragging it back, but I'm going to change this to go through all. Objects to cut will be both of these bodies, and we'll say OK. Now I have space to mount the 21 millimeter bearing on the inside of that housing and some room on the back side of this housing. We will need to add some additional material because the bearing is thicker than the wall housing. If we bring back body 3 and we right click on that feature that we just created, we can make it go symmetric or two sides. And the second side, we can drag it forward and set the distance to through all, allowing it to cut through all 3 portions. Notice in the preview that it's not showing it cutting through, and that's because when we modify this feature, we need to make sure that we include body 3 as one of the objects to cut. Because it was originally hidden for the first extrude, it's going to automatically be excluded, so you need to make sure that you toggle that option on if you want to include it in the extrude cut. Let's go ahead and add some additional geometry to the front of the housing to hold that 21 millimeter bearing. If you'll remember from the McMaster-Carr website, this 21 millimeter outside diameter bearing has a 5 millimeter thickness. If we take a look at inspect and we figure out the thickness of this housing, it should match 3 millimeters, which was the housing thickness value that we used. So we're going to start a new sketch on this front face. We're going to select create sketch. And using our center diameter circle, we're going to create a center diameter circle that's larger than the housing based on the housing wall thickness. We can do this by adding a dimension and begin to type H for housing wall thickness. And now we have a 3 millimeter thick section. I'm also going to use a center diameter circle in the middle, and this is going to have a 10 millimeter diameter. This is the size of the shaft that we need on the input and the output side. We're not necessarily going to use all of these in the same position, but we're going to make sure that it's all included in this one sketch. Remember that we have 3 millimeters of the wall thickness here, and we actually need to have 5 millimeters for the bearing. So we're going to create an extrude. We're going to just take a look at this wall. We're going to extrude it out a distance of 2 millimeters, which will give us the complete 5 millimeters for that bearing. I'm going to create a new body here and say OK, and bring back that last sketch. Next, I'm going to create another extrude, which is going to include both of those regions. To include both of these regions, it might become problematic if you have other geometry, so sometimes you might have to hold Control or Command down in order to reselect that geometry. What we're going to do from here, instead of cutting, is we're going to start at an object. So we want to start it at the end face that it's trying to remove. Notice that the extrude cut is automatically removing that face, so we need to reverse the direction. We're going to set it to a new body, and then we're going to pull it out a distance of wall thickness. So using that housing wall thickness and creating that new body, then hiding the sketch, will give us these 3 separate body sections, and now we can use combine to join them together. These could have been done as a join in the extrude, but sometimes it can be helpful to create them in their own sections, and that way we can go back and use combine later on. I'm going to use inspect and section analysis quickly I'm going to hold down the left mouse button and select my YZ plane to quickly take a look at what we've done. I'm not going to save my section view, but I want to note that we have a 5mm section here. We have our 3mm wall thickness, and this helps us include that 21mm bearing, and it has the 10mm opening for our input and output shaft. So I'm going to say cancel on the section view so that I'm not saving that analysis just yet. And I want to make sure that I do save this design before moving on to the next step.